This typed video is about correlation, causation, and accidental relationships. So let's look at two things. We'll call them A and B and say that they're related. Somehow we discover mathematically that there's a relationship between these two things. There's four main things that can happen. It could be that A caused B. It could also be that B caused A. So both 1 and 2 are causal or causation, but we want to be careful just assuming, oh, these look connected, one caused the other. It could be that A caused B. It could also be reverse cause and effect, that B is actually causing A. 1 and 2 are causation, but 3, it could be correlation. That is, another variable like C or maybe also D and E and other stuff caused both A and B to be affected. So we've got causation, we've got correlation, and now accidental. It looks like two things are connected, but it's just so implausible that they actually are affecting each other. They're just too far apart or too disconnected to really affect each other. Let's learn a little bit more about those three. Causation is when there's a direct cause and effect relationship, where one thing directly causes the change in the other thing. For example, snow causes slippery roads. Other things can cause slippery roads too, but when it snows, those snows on the road make the road more slippery. That always happens. It's a direct connection. Snow causing, maybe falling snow is more accurate, but falling snow on the ground on the road causes slippery roads. Undeniable. One caused the other. You also can have some people who deny climate change, and I don't want to get into that right now. What you cannot deny is that burning fossil fuels makes carbon dioxide go into the atmosphere. Carbon dioxide, for sure, is emitted. All fossil fuels have carbon. When they burn, the carbon it combines with oxygen to make CO2. So you can't deny that burning fossil fuels causes there to be CO2 in the atmosphere. That's causation. One thing causes another thing to happen. Correlation's a little bit different. That's when there's one or more other causes that affect these two things, but they don't affect each other much directly. For example, the amount of sleep you get versus your mark on the test. Sure, there's going to be some effect. Obviously, if you're got no sleep on an extreme, that's going to affect you. But it's not like every amount of sleep directly connects to mark on test. It's not like 5 hours of sleep, you get this mark, 6 hours of sleep, you get that mark, 7 hours of sleep. It isn't directly causing your marks. There's so many other factors, and those factors probably influence both your sleep and the test, like stress or things going on in your life or the fact that you were studying. So correlation, there's a connection, but usually something else is doing most of the affecting. They're not really affecting each other much directly. That's correlation. Accidental, on the third hand, is there appears to be some sort of connection between two things. Maybe it looks like causation or it looks like correlation, but then when you start to think about it, it's unrealistic or absurd. For example, the color of your eyes and your mark in class. There's no data or research anywhere that somehow would explain how your eye color could affect anything to do with brain development or learning. It would have to be coincidence. Even if somehow the colored eye people got one mark and another colored eye people got a different mark, it must be coincidence because there's no physiological reason why that affects learning. Same thing with reading books at night and having a snow day off school. If there's somehow you were reading books or a group of people read books and somehow the number of books related to snow day chances, it might look like there's a connection, but it's just not possible. How could books affect the weather? How could reading affect the weather? So that's causation, correlation, and accidental.